continuously compounded interest. You'll see this as an option, but I want to show you kind of how it was developed. So it just says at the very top, let's say you invested, I'm going to use the formula that we were using on Friday. So I'll just write it here so you guys can see it here real quick, but you don't have to write it on your paper. All right, so that's the compound interest formula that we were using on Friday. N is the number of times during a year that you compound. We're going to talk about continuously compounded interest today. So that's going to be a little bit different. So this is, let's say you invest $1. So that would be my principal at 100%. And I know this is kind of a weird setup, but the rate then, if it's 100%, does anybody know what the rate would be if you're investing at 100%? It's actually 1. All right, so 100% would be a rate of 1. And then it says compounded annually. So number of times compounded would also be 1 for 1 year. How much would be in your account at the end of the year? So all I would do, I'm just going to plug these in. So this would be 1, and then 1 plus 1 over 1 to the 1 times 1. Like it's a bunch of 1s there. So this would end up being 1 times 2 to the first, which is actually just 2. And if you guys look down here, I actually have that written in this very, very first. There's kind of like 3 columns here with different examples to kind of show this to you. So the question, or the little thing right next to it, this would be like right here. This would be twice a year, so it'd be semi-annually for this one. It's exactly the same. You can see if I just compound it annually, that value in the account would be 2. If I go semi-annually, it's just a little bit more. It's 2.25. And then this last example, this doesn't really have a special name, but it says N equals 100. So that means 100 times per year you would compound the interest. So on that one, again, they're just using that same basic formula I did at the top, and then you can see the value. They wrote out a bunch of decimal places. There's like 2.7, and as it gets a little bit farther out into the decimal places, they've got more there. Okay, now what I wanted to show you, and I don't know if you guys remember this from when we did natural logs. This is a whole list of just what the calculation would be for these different times. So like annually is once a year, semi-annually twice, quarterly 4 times, monthly 12 times. And then these actually give you, if I did it 100 times a year, if I did it 1,000 times a year, applying the interest and on down. And as you guys can see, this decimal starts to not really change that much. Like I started at 2, and it does go up for a little bit. But I mean, this last one I've got here, this is 1,000,000 times I compound the interest. And you can see this is kind of approaching a value. And the value that is approaching is what we were talking about with the natural logs. This number is that E. So that's where that came from. So if you did this example, but if I plugged in 2 million or if I plugged in 3 million for my number of times compounded, it would just get closer and closer to that number E. So this has its own special formula, but you got to see the words continuously compounded interest because we're doing it so many times that that's what gets it its own formula here. So this is called, some people call this, I call it the PERT formula. And it's very similar to what we were working on with the compound interest formula, but it's not quite as complicated. So for this formula, A is the amount in your account, right? The P is the principal. E is not a variable here. E is that number that you're seeing in this little chart, that 2.71828 going on there. R is still the interest rate, and T is still the time. So the E takes care of the number of times that you're compounding. So the E replaces that 1 plus the rate over N part from the continuously compounded, or just the compound interest formula. So we're going to be using this today. It's just going to be different buttons on the calculator. All right, so same concept. This says you invest $3,000, so that's your principal. That's what you're going to invest at a rate of 4.5%. So I'm going to do 0.045. Now, to distinguish, should we use the formula from our last lesson or should we use the formula from here, the little PERT formula? You are looking for the wording compounded continuously. It doesn't say like monthly or semi-annually. It says compounded continuously. That's how you're going to know that E is going to replace that little set of parentheses in the compound interest formula. And then this one for time is 10 years. This is a little bit easier to do because it's less things to plug in. How much are we going to have in the account? So you're just going to type 3,000. And then don't forget, E is not a variable. It's just a button on your calculator. Now the exponent here is going to be 0.045 times 10. So if you have an 84, you don't need parentheses. But if you have an 83 or if you have a scientific calculator, we're going to need to use parentheses around that exponent. We're just going to literally type this in. So 3,000. And then just to remind you guys, if you have 83 or 84, the E button should be second, and then it's the button kind of left of the 4. It says LN on it. So hit second LN. That should give you E. And then for your exponent, I'm going to do 0.045 times 10. Again, if you have an 84 or if you have an 83 or if you have a scientific calculator, just put parentheses around that exponent, and then you're done. So after, what is this, 10 years, we'd have $4,704.94. It's just a little bit different way to calculate interest. Okay, and then this is kind of like what we did on the last lesson. We're just going to do one example for each variable here real quick. So that was for the amount in the account. All right, this one says find the principal. So your account balance has $888.84. So that's the amount in the account, right? All right. What would you write down for your interest rate if I tell you 8%? 0.08, all right? Compounded continuously. That's what I'm looking for to know how to distinguish between which of the two compound interest formulas we want to use. So compounded continuously means I need to use the PERT formula with the E. And then your time here is 6 years. All right, so all we're going to do, I'm going to put the 888.84. My principal I don't know here, so I'm going to go ahead and use that as a variable. And then this would be E to the 0.08 times 6 power. Now, E is not a variable. It is that weird 2.718 number. So we are just going to take and divide both sides by what I just put parentheses around to get our principal. Okay, so how I would type this, I would do that 888.84 divide, and then if you have an 84, you shouldn't have to do it, but if you have an 83, just put parentheses around your exponent. I'm going to hit second natural log so I can get my E, and then I'm going to do 0.08 times 6. And what would you round that to? 550. All right, so I'm going to say the principal here was $550. Does anybody have any question or not seeing that on their calculator if they're trying that out? Okay. Now, this one's we're gonna find time in this one. Anytime you find time, that's gonna be in an exponent, and so we're gonna end up using a log. All right, so the 1275.48 is the amount in the account. If you originally invested $700, that's your principal. And let's see, interest rate 5%. How would I write that as a decimal? 0.05, good deal. And then how long was the money in the bank? So I don't know the time. And it does say the interest is compounded continuously. So I know I'm going to use that PERT formula with the E. Compounded continuously means I'm going to use E. All right, so the formula here, actually, let me write it real quick because I don't think you guys can see it. It's not on this page here. That's your formula. So the amount in the account is the 1275.48. The principal, what you invested, is the 700. E is not a variable, it is a number. And my exponent there, we're going to have 0.05 t is actually the variable that we're going to solve for. We don't know the time. Okay, now, this is probably not going to be a nice value, but let me look. I'm going to take that 1275.48. I'm going to divide that by 700 real quick. Okay, and I'm seeing a garbage decimal. So I don't want to round multiple times when I do this. Otherwise, it's not going to be accurate. So what you want to do here, I'm going to divide by 700. Okay, so I'm actually just going to leave 1275.48. If you're using a scientific calculator, you cannot use the fraction key to do this because it's got a decimal, but you could just use the division key. This will be e to the 0.05t. I'm just going to leave that since it was a really nasty decimal when I did that on my calculator. Okay, now, the only way to get that exponent down on the level with the rest of the question, we're going to convert this to a log. All right, so I'm just going to swing this over. So this would be log base e of that 1275.48 over 700 equals now on the level with the rest of the question that drags that exponent down 0.05t. Do you guys remember? I know this was a couple lessons ago, but a log base e is just a special thing for the natural log. Do you guys remember doing that? Okay, so all you have to do, you don't have to do a change of base or anything like that. What I'm going to do on my calculator, I'm just going to do natural log. That's the log base e of that 1275.48. We'll just type this right in the calculator, 700. And then that's equal to 0.05 multiplied by the time that this is in the bank. So after I do that natural log, we'll have to divide that by 0.05, but then we'll be done. So I'm just going to hit my natural log button. Should be the, just don't hit second with the button we were doing for E. Do 1275.48. You can't use a fraction key here. You have to just use the division sign. So I'm going to do natural log of that. And then I'm going to divide it because I'm multiplying my time by 0.05. So I'm just going to divide by 0.05. And then what would you guys round that to? This is just going to be 12 years. Is anybody having a question? Okay, I've got one more. If you're working with continuously compounded interest and you have to find the rate, that is going to be another situation where you need a log. If we did the rate for the regular just compound interest, it does not need to be a log, but for continuously compounded interest, it does. Okay, it says a retiree has $46,993.06 in an account set up from when they started working. So this is supposed to be the amount that you have in the account. If the person initially invested $1,000, so the $1,000 is going to be the principal, and the money was left in the account for 35 years, that's going to be the time. And then it does say compounded continuously, so that's how I know to pick the PERT formula. What is the interest rate? All right, so amount in the account is this $46,993.06. They invested $100. And then because we're compounding continuously, this is going to have E, and the exponent is the rate multiplied by the time. So the interest rate is what we actually don't know here, and the time is 35 years. So the exponent there is rate multiplied by time. Again, first thing I would do if I'm trying to get that exponent, where are my variables at? I'm going to divide the amount in the account by the principal. And let me see if that's a decent. It's not bad. Yeah, that's true. You do just move it up. So if you wanted to write that out, or if you guys wanted to leave it as a fraction, it's completely up to you. If you do put it as a decimal, write out all the decimal places. This is not repeating. It does stop. So I'm going to write that out. This is E, and I'm just going to kind of reorchestrate my exponent so my 35 comes in front of a R. Okay, all you got to do, get that variable out of your exponent is convert this to a log real quick. So this becomes, and skip this if you understand this, log base E, or log base E is just the natural log. So I'm just going to do natural log of that 46.06 46.99306. And that brings that 35R out of the exponent down on the level with the rest of the question. So we're just going to do natural log of that lovely decimal there. And then to get our interest rate, we're going to have to divide by 35. So just natural log button right next to the 4, 46.99306. Just go ahead, hit equals. And then I'm going to divide that by 35. Okay, now, what would I round that to? 0.11, right? Because that, there you got 99999, whatever. Okay, so 0.11. Now, that is your interest rate. If the question said to you, what would that be as a percentage? 11%. You would just take and multiply it by 100. It doesn't specify. It just says, what's the interest rate? I would take either one of those answers. You could say 0.11 or you could say 11%. But if you do have a question that asks you as a percentage, what would it be? Just multiply your rate by 100 to get that. Okay, is anybody having a question?